So here's what I can do with my agent right now, and it's pretty simple. I can actually restart some of my infrastructure virtual machines, and I can say like reboot the database server, and here it's got a human in the loop, and it said, and it is able to like look up my instances from my cloud provider and tell me, hey, do you mean like here's the database server? And I can say yep, and it says please confirm if you want to restart, and I can click on the approve button, or I can just say no, I'm good, and it'll just respond naturally. So again, here's something where I could create a workflow. And so is it worth creating an agent? Well, not right now, but it might be once I hook it up to my ops and my errors channel. So like if it receives an Azure Monitor alert for my website that says the website is down, and I give it access to Azure tools to diagnose what might be happening, and then it's able to determine, oh, there's something going wrong with the database. Do you want to restart the database, Kamran? And I just have to press a button. That saves me a whole ton of time. But we're not quite there yet, so I do want to show you what this looks like at the very beginning. So I have, let's see, my hosting provider is on vultr.com. So this is a cloud provider. It's similar to Azure, but I can do more bare metal VMs, virtual machines, and it's a bit cheaper. So that's the provider that I'm using. I do use Microsoft Azure for some stuff, but for my application servers, my database servers, I'm using Vultr because it is cheaper. But they do have an API, and it's a Node SDK. So Vultr Node SDK. All right. So this is the Vultr Node SDK. Now, because this is in JavaScript and TypeScript, it means that I can't really use some of these other frameworks. Like I can't use semantic kernel. I can't use AutoGen because the Vultr API is all written in JavaScript. And so I'm a TypeScript developer. Obviously, I'm a co-host of the TypeScript podcast. So I'm actually using something called Mastra. And Mastra is a TypeScript agent framework. Okay, so this is very similar to like AutoGen and semantic kernel, but it's written in TypeScript. So I'll show you a little bit about what that is. And then the other thing is because I use Slack internally. I know you guys use Microsoft Teams, but Slack has an SDK. And again, the Slack SDK is in JavaScript, Java, and I think it's just Java. Yeah, JavaScript, Java, and Python. And again, they don't have C# bindings, so they don't have a C# SDK. So basically, if I want to integrate with my tech stack, I can't use a lot of the Microsoft stuff. I need to use something like Mastra or something that's written in JavaScript. So why not TypeScript, right? So that's what I did. So let's get into it. Let me show you the solution here. So there's a couple things. First, the file structure here, we've got an entry point. That's my app.ts file. If I scroll all the way up to the top, you can kind of see how this app starts to get built. So I'm using the Slack Bolt SDK, which is essentially just a wrapper around Slack, the API, that lets you create AI assistants. And so you've got this like AI assistant class, and it listens to different events. And there's like a life cycle for when you use the assistant. So for example, let me just bring it up here. If I click on this button up at the top, which says chat with KTMG ops, I'll open it up, and then it says, hey, how can I help? And it lists some suggested prompts. Well, those prompts are right here. Restart the database, look up the user, and if it's inside of a channel, it can summarize the channel. Now, this is a built-in one. I don't actually use this, but that's an example. And so if we go look at the prompts, restart DB, look up user, summarize channel. Okay, so I'm inside of the KTMG errors channel, and I can summarize it. I'm not going to do that right now, but I can do some other stuff. So anytime I send a message back, it's going to trigger this user message. Okay. And this is really where the magic happens. This is where I basically hand off the responsibility to my Mastra agent. So I can pass it the thread ID, and this is the way that the Mastra agent keeps a working memory and a long-term memory. So I can scope it to the channel, or I could scope it to the conversation, just the thread. It depends on how much context I want it to be aware of. And so in my case, I want an ops agent, a DevOps agent that has context for previous errors that I had it work on or like diagnose. And so I want it to have the context for the channel, not just a conversation. So this is where I'm adding long-term memory. And then you can give it like the resource ID, which is usually corresponds to a user, like who is the resource that the agent is communicating with. So let's take a look a little bit about how we actually create this agent. You use whatever the Mastra SDK code is to create your agent instance. You give it these instructions. So like all these agents have instructions for like how they should act. And it sort of gives them some context of how to respond. And in fact, because I'm using a Slack agent, I give it explicit instructions to like format stuff for Slack. And then you give it the model that you want it to work with. So in this case, it's using the OpenAI model. But what's cool about the Vercel AI SDK is that you can actually use all sorts of other models. Like you could use Azure OpenAI. You could use a local, I don't know, Llama, Open Llama model. Do whatever you want. But since I already have an OpenAPI developer, I'm an OpenAPI developer. I already have that all set up. So it's just easier for me to use OpenAI. So I'm using GPT-4o Mini. And then here's where the cool stuff happens. You give it access to these tools, and you can give it any number of tools, and then you can also configure its working memory. Now its working memory is just a database. So it's in these little DB files, and that's all it is. So this is like, it's using libsql, which is like a vector database on top of SQLite. And so you can tell it, hey, store the last 40 messages that got sent to the agent, and then use that for semantic recall. So if I say, hey, what was in fact, let me just try it. What's the name of my database VM again? Let's see if it'll actually work. So what it should do is it should do semantic recall. Aha, there it is. The name of your database VM is RavenDB. Perfect. So because without that working memory, every single time I start a new conversation, I have to say, restart the database server. And then it says, what's the database server? I don't remember. And so now with semantic recall, it can do that. So let's go into this tool, this VM tool. So you remember that I said with Zapier, you couldn't easily like validate the parameters that get passed to your tools, your actions that you're trying to take. But with code, with a fully coded solution, you can. So with Mastra, it uses a library called Zod, which is a TypeScript schema validation library. And so you can tell it, here's the schema for the input and the output, and here's what the types should be. So for the VM ID, it should be a string, and it's the virtual machine ID. It needs a label that's also a string. It is a virtual machine label, right? And you can give it, here's what the output message should be. And then that context is how the model router figures out like what tool to use, because the AI SDK, the Vercel AI SDK, is that one that's actually doing the planning and reasoning for like what tool to use. So I don't actually tell it like here's what tool you should use. It just uses these descriptions and stuff for context to figure out what tool to use. Okay, once it calls this tool actually starts a workflow. So remember I said that if you have something deterministic, you're probably just going to have a workflow behind the scenes. So in this case, we do have a workflow. All we want to do is call the Vultr API, restart my VM, and then that's it. That's all we want to do. But we want the human to approve that restart. So this is where you can say in Mastra, you can suspend a workflow and you can resume it. So when you suspend the workflow, that's when you can ask for approval. And so here's where it says, hey, the status is suspended. So I'm going to return a message that gets passed. It's either a string or it's an object that contains a blocks property. So here's your blocks. This this structure, if you're not familiar with it, is a structure that gets passed straight up to the Slack API, because Slack has a capability called block kit, which powers these buttons here. So here, this is what the message structure of this approve button is reflected here inside of this JSON structure. So this accessory type button has the word approve on it, and this is the value. It's just a URL search parameters string, which is a URL string, and I'm passing it, here are the parameters that I want to get back when I want to resume the workflow. So once I click this button approve, that's what the values are going to be. Now that gets handled back in the Slack layer. So again, the Slack SDK allows me to listen to these actions like resume workflow, and I can respond to them. And so that's where the parameters get passed in. I can parse out those parameters, and I can, for example, pass them back to Mastra to go get the workflow. And if the workflow is suspended, I can then resume it. Or if the workflow doesn't have a valid run, like a run ID, which is the instance of the workflow that's running, it can say, hey, I didn't find that workflow. So here's where it's actually passing the run ID, and then it says, hey, looks like the run didn't exist if that didn't work, but otherwise it resumes it. So it calls run.resume. It passes in the new step that it has to go to, and the new context. So here, back in the VM tools, actually in the workflow, there's these two steps. And here's where I'm passing in. Initially, this is the review step. Please confirm if you want to restart the VM with the label. Guess where we saw that? Please confirm if you want to restart the VM with a label. So that's hard-coded. And so this is what it's doing. And then during the restart is when it actually calls the Vultr API and reboots the instance. So it only does that if Slack receives a callback from that button. Okay? So there's a lot here. So let me just switch over to my slides again, because we're done with some of the live demo. Okay, so at a high level, you've got several building blocks that I've talked about, right? There is a server that's hosting a listener for Slack messages and actions, and that's provided through the Slack Bolt SDK, which is through Node.js. Then a Slack event, like the conversation started event, is what hands off to the Mastra agent. The agent can call tools, which can themselves trigger workflows, which themselves can trigger other tools. So they can call each other, at least in Mastra. And I don't know if I 100% like that, but that's how I had it set up right now. I think what would be ideal is if the agent could actually just invoke the workflow from the user intent rather than me having to call it manually through a tool. But anyway, once the user takes an action, so the workflow gets suspended, right? If I want to do a human in the loop, the workflow gets suspended. It's returned as a Slack response, which gets sent back to the user in the conversation thread. And then the user can take an action, like clicking that approve button, and then the action callback resumes the workflow that the action corresponds to. And that memory of the agent is at the channel level, which gets stored in long-term working memory for recall, and that's through that libsql vector database. And it also sends recent conversation history as context. So there's all these different building blocks going on. How does my custom agent fare against the impact framework? Pretty well, I think. So as you saw, I delegated to tools to poke at my infrastructure, like to list VMs or restart VMs. I was able to implement a human-in-the-loop strategy for approvals. It does route between tools using the LLM. Like there was no code that I wrote that told it use this tool. If I said, what is the name of my database, it was able to use semantic recall to figure that out rather than calling the list VMs tool. And so it has that long running memory with that database. But where it does lack still a bit is in its multi-step planning. So for example, if it fails to use a tool or there's an error, it's not going to retry or figure out what to do next. At least not yet, but that kind of reasoning and multi-step planning is actually coming to Mastra. It's just experimental right now, and I don't have it implemented. So rather than defining a workflow where I manage the control flow myself, an agent network, it's called, actually uses LLM planning to figure out what agent to use and then sets up a multi-agent architecture. And I think that this is sort of where the future is headed for these agents. Now, if you've seen Crew AI, it's basically like that, where you're able to define multiple agent roles and then you have them work together to accomplish tasks. And this, I think, is definitely where most of the agent frameworks are heading. And I think it's where these agentic systems will become much more useful. Because remember that I said at the beginning, wouldn't it be nice if it could respond to my availability alerts? Or there's failure anomalies happening in my metrics for my website, and it's able to determine what it should do and diagnose it on its own. And I could do that using an agent network. So that's sort of my next step for this production ChatOps agent.